Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series on edge effects. In this clip, we show that many rollers have an uneven temperature profile, especially on the edges. This uneven temperature can cause edges to be different than the rest of the web, especially in web converting, forming, or manufacturing. We will show that even idler rollers can cause edge troubles in certain rare cases. I know your time is precious, so let's get started. Recall from the first clip in this series how most internal rejects and most customer returns come from the edges of the web. Also, we note that the temperature really matters, especially for certain converting, forming, and manufacturing operations. In this clip, we show how temperature is non-uniform, especially at the edges, and why this may be responsible for some of the misbehavior at the edges of some webs. We learn about methods for heat transfer in Module 16 in the advanced portions of our award-winning and trademarked Web 101 class. These are essential tools for the manufacturing of certain webs, such as cast film and metal and paper and many more. These are essential tools for certain converting operations, such as calendaring and coding and printing and many more. What is most useful to know here is that all of these operations tend to be quite imperfect at the edges. All have the tendency to be hotter or cooler at the very edges than in the center, as shown here. This means, in many cases, that the edges will be formed different than the center, and that can be the root cause of some complaints about edges. We also learn about troubleshooting in my 2-day critical thinking class, as well as a Tappy Press book of the same name. One real-world example I teach among the dozens of real-world examples how even an idler roller can cause baggy webs if the temperature is uneven. In that module, you will learn why science and experience and conventional wisdom may all yield no answers, or worse yet, the wrong answer. That is why troubleshooting skills are as important as knowledge, even though they are seldom taught in either school or industry. At this point, you are probably thinking, well, why not just fix the edges? Well, we would if we could easily, but machine edges are inherently imperfect. While we may have many options, some of which are shown here, all cost more money. Alternatively, we could trim away more of those troublesome edges, but that also costs money. Or we could just leave it be, and then we have more customer complaints and internal rejects, and that costs more money. Those of you who follow my work will readily recognize this situation is perfect for economic optimization. Thank you so very much for joining me in this Edge Effect mini-series. Please join me next week, where we will continue our discussion of edge quality challenges by talking about certain operations that cause the edges to be relatively thicker, and how that could cause baggy edges. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.